How you can use your CAS to solve the differential equation from work example 18. So we can solve dx dt equals 1000 kh squared on pi r squared x squared using the CAS to find a general solution. We can also find a particular solution for the initial condition that we had where x equals 0 and t equals 0. So what we'll do, we'll just get our CAS. So it's dx dt equals 1000 kh squared is the first part. So I'm going to use DE solve, which you can get in the menu. So DE solve. Now it's dx dt, which we're going to write as x dash. So use the little dash. So x dash equals, and it was 1000 times k times h squared. And I'll put all of that in brackets actually just to make sure that it doesn't get confused. And then we're going to divide all of that by pi r squared x squared. So brackets pi from the pi menu times r squared times x squared. Now this differential equation has to be solved with respect to the independent variable first, which is t, and the dependent variable, which is x. It's funny because normally our independent is x and our dependent is y, but here it's dx dt. So x is the one with the dash and x will be last here. If we push enter, you'll get your solution for the differential equation, but you can see it still has a constant in here. That C7 is a constant. So let's solve this differential equation where we're actually using the condition that we had, which was x equals 0 and t equals 0. So what we do is just after the differential equation, put a space, type and, another space. Now when t equals 0, inside the function, so normally we'd write our function as x of t equals something. Well, we know that when t equals 0, x equals 0, like that. So now we can push enter on that, and that's the solution that we get. Now it looks a little bit different to the solution we had found by hand, but let me just take that over and have a look at it. I'll just put it there. So you can see, let's compare. You've got here the cube root of 3000. What they've done is they've actually taken, this is all the cube root part here with the little third power. So they've kept the 3, the k and the t inside there. With the squared power on the h, they've turned that into a 2/3 here. So that's the 2/3 part, that's the cubic part. And this part, the 1000, they've actually found the cube root of 1000, which is 10. Okay, underneath the same thing's happened. Pi is still the cube root with that power of a third. And then here, because the r is a squared, the cube root of a squared power is 2/3. So that represents that part. So this particular solution, even though it does look a little bit different, is actually completely equivalent to the one that we got this way by hand. So that's just a handy way of using your CAS to solve a differential equation, particularly one that has